Hi, I'm Caroline. So you've worked out the number of moles, but now what? In this video, we'll dive into molar ratios, how to read them from balanced equations, and how to use them to solve more involved chemistry problems. It's a key step in nearly every calculation you'll face in exams. If you need more help on calculations, I've got a full series breaking it down all step by step. So hit subscribe right now to follow along and let's dive in.
Let's start with exactly what are molar ratios. So molar ratios tell you how many moles react together. So if you have a reaction where substance A and substance B are reacting, it tells you what ratio they are reacting in. They also allow you to work out how much product is made. So if you know the moles of one thing, any reactants or any product in that equation, using molar ratios, you can work out the moles of all of the other substances. So that balanced equation, what it's really telling you by those big numbers is how many moles are used up or are made in a chemical reaction. Let's look at this example here. So here we have C2H8. Now there is no number, no big number in front of that, which means it's a 1. The big number is 1, we just don't write it in. And that will react, so one of those C2H8 will react with 4 oxygens. That's what that big 4 means, 1:4 ratio. Then, if we look at the products, it means that we are making 2 carbon dioxides and 4 waters. But watch out for this common mistake. You only use these big numbers when you're working out the moles of the other substances in the reaction. You don't use them when you are calculating formula masses, otherwise known as MRs. This is all going to become a little bit clearer when we put it together as a skill into a reacting mass calculation. So you can always skip ahead to the next video when I put all of this together in one place and how to actually answer a calculation like this. Let's have a look at the moment at just getting really confident at using these molar ratios. Let's look at an example. So here we have iron oxide reacting with carbon, and that's going to make iron and carbon dioxide. What those big numbers mean is that 2 moles of iron oxide will react with 3 moles of carbon. That will make 4 moles of iron and 3 moles of carbon dioxide. Now, let's have a look at the first row. So example A here. We are given just the moles of iron oxide as 4 moles. Now we're going to apply these big numbers as a ratio. So the ratio between the iron oxide and the carbon is 2:3. So we're thinking, right, well, how do I apply that ratio? So if it's 2:3, it becomes 4:6, because that ratio is just doubled up. 2:3 is the same as 4:6. Let's keep going and apply that all the way across. So for the iron, if we have 4 moles of iron oxide, then we must have 8 moles of iron, because that is a 2:4 ratio. 2:4 is the same as 4:8. And then finally, the carbon dioxide. So the carbon dioxide, if we look at it compared to the iron oxide, that's a 2:3 ratio again. So therefore, we're going to make the same amount of carbon dioxide as we used of the carbon. Both of those have a big number 3 across. So it is therefore 4:6:8:4. See that? 4:6:8:6, sorry. Now let's look at example B. So here we're given just the carbon and 5 moles of that carbon. Let's apply the ratio in the opposite direction this time. So carbon to iron oxide is 3:2. Now this might be a little bit harder to figure out in your head. So what you can do is divide by the first number in the ratio and times by the second number in the ratio. So my carbon is 3, my iron oxide is 2, so I'm going to do 5 divided by 3, the first number, the 3, and then times by the 2. I can do the same then to find out the iron. So the carbon to iron ratio is 3:4. So I'm going to take that 5, divide it by 3 and times it by 4. For the carbon dioxide, that's just a 3 to 3 ratio, so that's just 5 moles. So pop that into your calculator if it's a little bit too much to do in your head. To recap, we took that 5 moles of carbon, we divided it by 3 and then times by 2 to find the moles of the iron oxide. To find the moles of the iron, we divided by 3 and then times by 4. And then for the moles of carbon dioxide, it's just 3 to 3, which is the same as 5 to 5. Now let's look at the final example. So we're now given 0.6 moles of iron. So let's work that out for the carbon dioxide first. So iron to carbon dioxide is a 4 to 3 ratio. So we can do this on our calculator again. We're going to divide by the first number 4 and then times by 3. So 0.6 divided by 4 times by 3. That's the moles of carbon dioxide. Now let's work back towards the reactants. So the iron to carbon ratio is 4 to 3. So that's the same as the one we've just done. So take the 0.6 divided by 4 times it by 3. And then finally the iron to iron oxide ratio, that is a 4 to 2 ratio. So we take the 0.6 divided by 4 and times it by 2, which is the same as halving it, which is 0.3. So there's our final row of answers.
Thanks for watching, and if you found this helpful, then hit subscribe now so that we can keep learning together and we can make chemistry make sense for you so that you can get the best possible results